in the second experiment, what I will do is I will put the switch in delta configuration and I will only switch on a purely resistive load. With this purely resistive load, the difference in the reading should be that the power factor in both the meters should be 1 in theory, because the resistive load is a unity power factor load, and by calculation also the power factor will come to 1. So let us start by doing the experiment. है अभी 10 मिनट में जाएंगे कौन से को एक नंबर दुकान पे ठीक है. Now that we have switched on the panel, you must have observed that we have changed the output from the inductive load to the resistive load. We have connected each phase to the input of a resistive load. Now that I have set the switch 1 on, I will apply the. Now that you have seen, I have set the load to delta position. I will note down my readings. My readings is 179 watt and 175 watt. 179 watt and 175 watt. Now I have already made the calculation with these readings as I will show you right now. Now this is the connection that is being made. Between R and Y phase there are two bulbs that are connected in series. Between Y and B phase there are two bulbs that are connected in series, and between R and B phase two bulbs are connected in series. These are my wattmeter readings, 181.4 and 178.4, and my power factor from calculation is from reading of the wattmeter is 1, and this is my power factor calculation from my using my calculator, in which I have used the formula phi is equal to cos into tan inverse of root 3 W1 minus W2 upon W1 plus W2, as I have used earlier. This is the formula that we will be using to calculate. So that this calculation simply says that the calculated power factor is equivalent to the reading from the wattmeter. So our power factor calculation is correct, and this is the power factor for a delta connected purely resistive load. So let's move on to the next experiment in the next video, in which we will be connecting a star RL load to in a star configuration to a 3-phase supply.